Welcome back to IM1, everybody. Today's topic 3.13. What is the relationship? And we're looking at the slopes of parallel and perpendicular lines today. So, the lesson objective will be by the end of this lesson, I'll be able to discover the properties of lines of reflection and their slopes. So, let's look at the first question right there 325. At the right of triangle PQR, at right, triangle PQR was refracted across line L to form triangle P prime, Q prime, R prime. Describe the relationship of the original triangle and its image to the line of reflection. So here you have your line of reflection, right? And then your 2 points are being reflected, right? Q prime, P prime, R, and R prime. So what is the relationship between the points and the line of reflection? So pretty much you guessed it, that the original image is the same distance as the reflected image to the line of reflection. Is the same distance to the line of reflection as the reflected image. All right. So if you guys were to grab everything right, they're directly across. You guys see that? They're all directly across and they're all the same distance right there. All right. So let's look at problem 326, connections with algebra. So in problem 325, you made some observations about reflection. So slope can reveal more about such transformations. So begin by graphing the equation y equals 3 over 5x minus 4. Use tracing paper to translate the equation y equals 3x minus 4 up 5 units, and then write the equation of the resulting image. What is the relationship between y equals 3x minus 4 and its image, and how do their slopes compare? So you guys can use Desmos to make the graph of the original one. So we have y equals 3 over 5x minus 4. So we're going to go by ones on the x and the y axis. So here I'm going to start at the center as always, and then I'm going to go down 4. That's my first point. And then from there, I go up 3 and then 5 to the right. So up 3, 5 to the right. And that would be pretty much my line. Alrighty. And now it says use it. So we're going to move this same line right here, right? We're going to move it 5 units up, right? So 5 units up. That's what we're going to do. So let me copy this line itself. And then let's move it 5 units up. All right. So this is our line. I don't need these two right here. So this is our line, right? So we started off here, and then we're going to move it 5 units up. So that's 1, 2, 3, 4, 5. All right. So now that's our new line. Let me label it as the new line. And then this is the original, right? So again, what is the relationship between y equals 3x over 5 minus 4, and then how do their slopes compare? So we can say it looks to be the same line, right? So they seem to be parallel in this case. So the lines are parallel. The lines look parallel or are parallel. All right. And then pretty much we can say that the slope, right? The slope. So first let's find the slope for the original one is y equals 3 over x minus 4. And then let's find the slope for the new one, or the equation for the new line. So this one starts off here. We go again using a slope triangle. We go up 3 and then 5 to the right. And then our y-intercept is 0, 1. So what I'm going to do now is pretty much write the equation of the original. So y equals 3 over 5 times x plus 1. All right. So how do their slopes compare? Right? We're looking at them now. How do these compare? So pretty much they're the same, right? They are the same. Oops. They are the same slope. All right. So we can say that every time we see two lines that are parallel, we can say that they have the exact same slope. All right. Now let's look at problem B. It says use tracing paper to rotate 3x minus 4 90 degrees clockwise about the center, right? Write the equation of the results and then describe the relationship of y equals 3 over 5x minus 4 to its new image. So we will want to do next, again, let's make the original graph, right? We'll do it in green. So y equals 3 over x minus 4. So again, same thing. I'm going to go by ones on the x and the y axis. So up 3, 5 to the right. And again, that's my line right there. And then it says I want to rotate this about the center, which is right here. Oops. So the center is right there. So if I were to rotate 90 degrees clockwise in this direction, right? So let me look at this line, see if I can copy it again. Copy and then paste it. All right, so that's our line. And then I want to rotate that line 90 degrees. So I'll do it with this because that's going to help me right there. So 90 degrees. So if you guys have noticed, I've rotated the line 90 degrees about the origin. Just got to make sure that it's in the right place. I would say about right there. All right. So that's 90 degrees. So now let's find the new slope. So if we look right here, let's create a slope triangle, right? So we have one right here and then another one right there. So from here, I'm going to go down 5 and then 3 to the right. So down 5, 3 to the right. All right. Over 3, I think it's going to be more over this way, actually. Yeah. The slope's still the same, believe it or not. Okay. Let me erase that so you guys won't get confused. All right. So now it's rotating 90 degrees. Sorry about that. So again, I go down 5 and then 3 to the right to pretty much get the next point. All right. So one of the things that I want you guys to notice here, all right, so the new image has a slope of y equals negative 5 over 3 times x, and then we want to find the b value. Now, we can pretty much find the b value by locating a point on the line that's part of it, right? So let's make it an easy point, 3, 2. This one right here, 2, 3, I'm sorry, 2, 3. So we're going to substitute. 3 equals negative 5 over 3 times 2 plus b, right? And then that's going to give us negative 10 thirds plus b. That's 3. You want to add 10 thirds to both sides. All right. And that's going to give us pretty much 3. That's 9 over 3 plus 10 over 3 equals b. So that will give us 19 over 3. So that's our b value, and therefore our equation looks like our new equation, y equals negative 5 over 3x minus 19 over, actually plus 19 over 3. Now, again, what is the relationship between this slope and this slope? So this is what we call the negative reciprocal, right? So the slopes are negative reciprocals of each other. All right. And then from here, So let's look at the next one. The original line and the rotated line part B are perpendicular because they form a 90-degree angle when they intersect. Look at the slopes of the original line and rotated line. Make the observations you can about the relationship, right? So again, in this case, the slopes are negative reciprocals of each other. So if you notice, m for the original is equal to 3 over 5, and for the transformed, right, is negative 5 over 3. All right. So when you have a number, if it's a fraction, like 1/2, the negative reciprocal of that would be just negative 2 over 1. So you just pretty much flip it over and make it negative, right? So again, the slopes are the negative reciprocals of each other, right? So if the slope of 1 is a over b, the slope of the perpendicular line is going to be negative b over a. And that symbol right there is for perpendicular.